Space, the final frontier. Come with us as we explore and unravel the mysteries of what lies beyond our planet Earth. Strap yourself in. Get your spacesuits ready as we prepare for takeoff in T-minus 5, 4, 3, 2, 1. Welcome to Inside Outer Space. Milky Way. It's the star cluster that we call home. Welcome to the Milky Way galaxy. The Milky Way is a galaxy or a giant cluster of stars which our planet, the Moon, the Sun, and the rest of the solar system belong to. Its name comes from the fact that the huge amount of stars at night appear like bands of milk in the night sky. Before we dive in, let's talk about galaxies first. A galaxy is a gravity-bound system that is comprised of stars, planets, gases, dust, and other interstellar debris. Actually, the word galaxy itself comes from the Greek term galaxias, which literally means milky. This is in reference to the milky appearance of the Milky Way galaxy. In Greek mythology, it is said that Zeus placed his infant son Hercules on the goddess Hera to be breastfed. The Milky Way is said to have been formed from some of the milk that was spilled in the process. Galaxies can be categorized according to size and according to shape. Sizes can range from dwarf with a few 100 million stars to giants, which has stars in the number of trillions. On the other hand, galaxies can also be classified into shape or morphology. Examples of which include spiral, elliptical, ring, lenticular, and irregular. Now let's zoom in a bit to the Milky Way galaxy. The Milky Way is a barred spiral galaxy, and it has a huge diameter, which is approximately between 100,000 to 180,000 light years. It is estimated that the Milky Way contains somewhere between 100 to 400 billion stars, with at least 100 billion planets. The solar system is located somewhere approximately 26,000 light years from the Milky Way's galactic center. The center of the Milky Way is marked by a high-intensity radio source, which astronomers call Sagittarius A. Some scientists suggest that Sagittarius A may be a supermassive black hole and is responsible for creating the strong gravitational pull, thus keeping the stars in the Milky Way together. The Milky Way and nearby galaxies form a local group, which is called the Virgo supercluster. On a clear night, we can see part of the Milky Way on Earth. It has a hazy white appearance, which can be viewed 30 degrees across the sky. On a side note, technically, all the stars visible on Earth is part of the Milky Way. On a clear night, however, the light from the Milky Way can be seen on Earth, but that's just a small part of it. That's because the Earth is so small compared to the size and mass of the Milky Way itself. Enceladus. It's one of the most studied moons this side of the solar system. Today, let's find out why as we talk about the moon named Enceladus. Enceladus is the sixth largest moon of Saturn. It has a diameter of approximately 500 kilometers or 310 miles. Enceladus itself is covered by fresh clean light. This makes it one of the most reflective objects in the solar system. It has a surface temperature of negative 198 degrees Celsius or negative 324 degrees Fahrenheit. Enceladus orbits around Saturn with a period of 1.4 Earth days. Enceladus was discovered by William Herschel. If the name sounds familiar, well, you guessed it. William Herschel is the same person who discovered the planet Uranus, among others. Herschel used a 1.2 meter or 3.9 feet telescope, which was at the time considered as the largest in the world. Enceladus is named after Enceladus the giant from Greek mythology. Enceladus was the son of the goddess of the earth Gaia and the god of the sky Uranus. William Herschel decided to name his discovery after it at the insistence of his son John. And here's where it gets interesting. Scientists discovered something amazing when the Voyager spacecraft first took pictures of Enceladus in the 1980s. The pictures reveal that Enceladus has a clear icy surface. The icy surface on this moon gives it a very reflective appearance. You can think of it as a large space mirror. This feature is what makes Enceladus one of the brightest objects in our solar system. Further observations suggest that this moon may be composed of a rocky core, frozen ice water, and a frozen mantle. Additional examinations of the planet suggest cryovolcanic activity. This means that there may be active volcanoes underneath the icy surface of this moon. As these interior volcanoes erupt, small geysers appear as cracks on the icy surface of Enceladus. The Cassini spacecraft was able to take images of the geyser activity on the moon's surface during its close-up flybys of Enceladus from 2004 to 2015. Scientists think that the material ejected from these geysers form part of Saturn's rings called the E-ring. The volcanic activity and the presence of water in Enceladus leads many researchers to wonder if Enceladus can develop life, or at the very least, have the potential to be habitable by humans. If you think about it, Enceladus could potentially be a small Earth with its rocky core, volcanic activity, and icy oceans. For now, there have been some proposals to further explore Enceladus, and perhaps even bring some samples from the moon back to the Earth for further study. And who knows, maybe humans will be visiting or even living in Enceladus in the future. Saturn, the sixth planet from the Sun, coming in with a diameter of 120,536 kilometers or 74,897.6 miles and a mass of 5.68 times 10 to the 26th power kilogram or 1.253 times 10 to the 27th power pounds, equal to 95 Earths, with 62 moons and 30 rings, and an orbit period of 10,756 days, or 29.5 years, with a temperature of approximately negative 178 degrees Celsius, or negative 288 degrees Fahrenheit. It's the planet with the awesome ring system and is the farthest planet seen by the naked eye. Welcome to Saturn. Saturn is the fifth brightest object in the sky. It can easily be seen without the aid of telescopes. Saturn takes its name from the Roman god Saturnus. The planet has been known by the ancient people from Babylon and the Far East. Saturn is mostly composed of hydrogen layers that get denser as it gets closer to the planet's core. The core is said to be made of a metallic composition with a hot inner core. Saturn is a gas giant and has different layers of gases. Its atmosphere is divided into different bands of clouds that are composed of ammonia ice, water ice, cold hydrogen, and sulfur ice. Among the other planets, Saturn has the most elaborate ring system. The rings are mostly composed of ice and dust debris. The rings stretch out to more than 120,000 kilometers or 74,564.5 miles, but are only 20 meters or 65.6 feet thick. Saturn has many moons, and some of its larger moons have been observed to have oceans below its icy surface. Today, there have been 4 spacecrafts that have visited Saturn. These are Pioneer 11, Voyager 1, Voyager 2, and the Cassini-Huygens mission. Tides. Here's another example of interstellar bodies affecting each other. It's closer to Earth than you may think. So for today, let's talk about tides. Tides are the rise and fall of the water levels in the seas and oceans of the Earth. This rise and fall is caused by the Moon's gravitational force that it exerts on the Earth's waters. When the Moon is closer to Earth, its gravity exerts a pull on the Earth's surface. This gravity is less than the Earth. That's why the Earth does not get pulled in by the Moon. But it's enough to cause water in the seas and the oceans to rise. When the Moon's gravitational pull is at its highest, this results to what's called a high tide, a period where ocean levels are high. On the other hand, when the Moon's gravitational pull is at its lowest, this results into what is called the low tide, or the lowest water level of the tide. In case of a full moon or new moon, the sun also affects the level of the tides together with the moon. During these phases, the high tides are at its highest and the low tides are at its lowest. These type of tides are known as spring tides and are especially strong because of the combined gravitational pull of the sun and the moon. During the moon's quarter phases, however, the sun and the moon are at right angles to each other. This causes some of their respective gravitational pull to cancel out each other. This results to a weak type of tide called neap tides. Since the Earth, Moon, and Sun move in a consistent pattern, tides can be accurately predicted. The ancient peoples of Earth have studied this extensively and have accurately predicted tides for hundreds of years. This is especially helpful for people living near coastal areas to prepare for rising water levels. Tidal data also helps seafarers with navigation, especially in areas that are shallow and narrow. Engineers are also reliant on tidal patterns and data when designing structures over bodies of water like bridges and docks. Tidal data also helps small-scale industrial and recreational fish-catching activities. Knowledge of tides helps improve the quality of catches as certain fish favor specific tidal conditions. Marine habitat restoration activities are also dependent on tidal activity. Tides also determine the flow of sea and ocean traffic, especially in active routes where many ships and vessels pass by. And finally, tidal data are also useful for sports and recreational activities in the oceans and seas. Eclipse. Here's another interesting phenomena in space that you can observe right here on Earth. Today, let's talk about eclipses. So what are eclipses? Well, eclipses are the name given to the phenomenon when a celestial body, like the Sun, is obscured by another celestial body. This happens when a celestial object passes behind or in front of another object, thus obscuring the view and casting a shadow from the observer's viewpoint. The term eclipse actually comes from the Greek word eklypsis, which translates to abandon or darken. Before people knew what eclipses were, they used to associate eclipses with disaster and bad omens. In some cultures, eclipses were thought to be caused by giant monsters swallowing the sun. The most common type of eclipse that can be observed in the Earth is the solar eclipse. The solar eclipse occurs when the moon passes in front of the sun, slightly covering it as observed from the vantage point of Earth. Another type of eclipse is the lunar eclipse. This happens when the Earth blocks the sun in reference to the moon's position. Lunar eclipses can only happen during the full moon, when the moon is at the far side of the Earth. Because of this, a lunar eclipse can only be seen on one hemisphere of the Earth. When eclipses occur, there are usually shadows cast by the blocking object to the blocked object. The region of the blocked object is divided into three parts. There's the umbra, the area where the object completely blocks the light source. Then there's the antumbra, the area where the object is completely in front of the light source but is too little to be able to cover the whole light source. And finally, there's the penumbra, or the region where the object is only partially blocking the light source. A total eclipse happens when an observer is inside the region of the umbra. On the other hand, when the observer is at the antumbra, the eclipse is called an annular eclipse. And lastly, the eclipse is called a partial eclipse when the observer is within the region of the penumbra. For lunar eclipses, only the umbra and the penumbra are visible. That's because of the size of the moon. From the moon's viewpoint, the Earth's apparent diameter is nearly 4 times that of the sun. Since ancient times, people have been keeping track of solar eclipses. The purpose of this is to serve as important markers or reference points with regard to solar events of the era. One of the earliest records for a solar eclipse comes from a Syrian tablet dated from 1223 BC. Another one can be found in an old Irish record from 3340 BC. Elsewhere, ancient Chinese astronomers have kept solar eclipse records for over 4,000 years. A look into the past. The telescopes that we have lets us look at objects light years away. When we look at objects in the sky, we're actually seeing it from a much earlier point in time. The effect is so that it is as if we are peeking into the past, much like how a hypothetical time machine does. But how? Well, consider this. Humans are able to see things because of the light that is reflected of our eyes. When light hits an object, it reflects back to our eyes, and our brain processes the image. This is how we can see. Now, this process of reflecting light happens at such a fast pace that we hardly ever notice it. But what if the light that we see needs to travel a far enough distance before it reaches our eyes and brains? Remember that light travels fast at a rate of 300,000 kilometers per second, or 186,280.397 miles per second. The nearest star to Earth, the Sun, is still 149.6 million kilometers, or 92.96 million miles away. Even at the speed of light, light from the Sun will take around 298.6 seconds before it can even reach Earth. Exactly the time it takes for us to see sunlight. Enter the light year. The light year is a measurement of distance that is equivalent to the distance that light can travel in a year, which is somewhere along 9 trillion kilometers. So if something is a light year away, it would also take the light from that object exactly 1 year before it can be seen. For example, the nearest star cluster to our own Milky Way galaxy is the Andromeda galaxy. Andromeda is around 2.5 million light-years away. Because it's 2.5 million light-years away from Earth, the Andromeda galaxy that we are observing is the Andromeda galaxy as it was 2.5 million years ago. And that was another interstellar trip across the universe. Remember to join us next time for another mission to the cosmos and beyond. Only on Inside Outer Space. Space. The final frontier. Come with us as we explore and unravel the mysteries of what lies beyond our planet Earth. Strap yourself in. Get your spacesuits ready as we prepare for takeoff in T-minus 5, 4, 3, 2, 1. Welcome to Inside Outer Space. Black holes. It's not just the stuff of science fiction. For years, the mysteries surrounding black holes have been tugging at scientists and researchers. But truthfully, we have barely begun to scratch the surface with what little we know. Generally, a black hole is described as a region in space and time that has such a strong gravitational pull, So strong in fact that nothing, not even light, radio waves, particles, and radiation can escape it. Because of this strong gravitational pull, scientists and the best of Earth's technology still cannot directly observe a black hole. So how are we able to observe it? Well, scientists indirectly observe the particles and radiation that are being drawn into the black hole. So where do black holes come from? Scientists theorize that black holes are formed when a star collapses in on itself. When this happens, the star's mass becomes densely packed, and this exerts a very strong gravitational pull. This strong gravitational pull then starts to attract nearby space objects like dust and other space particles, which contributes to the growing size of the black hole. Scientists have identified two layers of a black hole based on what can be observed here on Earth. The first layer is called the event horizon. This is the point in the black hole where light can no longer escape. Meanwhile, the second layer is called the singularity. The singularity is the point where all of the mass of a black hole is concentrated. Black holes come in a variety of sizes. The smallest type of black hole is called the primordial black hole. Scientists believe that this type of black hole is as small as a singular atom but has the mass of a big mountain. On the other hand, a stellar black hole is considered as the medium-sized black hole. Stellar black holes have a mass that can go as 20 times greater than the mass of the Sun. Many stellar black holes can be observed in the Milky Way galaxy. The largest black hole is called a supermassive black hole. These black holes have a mass that is larger than the mass of 1 million suns. Scientists think that each large galaxy has its own supermassive black hole in its center. The supermassive black hole of the Milky Way is known as the Sagittarius A. So, is the Earth and the solar system safe from the threat of a black hole? Currently, there are no known black holes observed in the solar system. Hypothetically, however, if the Sun would collapse on itself, the resulting black hole's gravitational pull would have to be greater than that of the Sun for it to be able to attract nearby objects in the solar system. Otherwise, the planets would just revolve in orbit around it. Olympus Mons. Today, let's talk about a particular landmass on the surface of Mars. Mountains, volcanoes, and other surface features are not just exclusive to Earth. Let's just say, if the Earth has Mount Everest, then let us introduce you to Mars's Olympus Mons. Olympus Mons is not really a mountain per se, but it is actually a very, very large shield volcano on the surface of Mars. It has a height of 22 kilometers or 13.6 miles. That's almost as tall as about 2.5 Mount Everests on top of each other at above sea level. Currently, it holds the record as the tallest mountain of all the planets in the solar system. Olympus Mons takes its name from the Latin form of Mount Olympus, or the mountain where the gods of Greek mythology lived. Scientists think that Olympus Mons is the youngest of the large volcanoes on the surface of Mars, formed sometime 3,700 million years ago. in the year scientists call the Hesperian period. A period in time on Mars characterized by widespread volcanic activity and catastrophic flooding. Olympus Mons can be found in the Tharsis Montes region of Mars. This region is roughly near the equator of Mars. Olympus Mons is one of the many volcanoes in the area. For comparison, here's how big Olympus Mons is when compared to some popular land masses on Earth. It has a height of 22 kilometers or 13.67 miles. Meanwhile, back here on Earth, our tallest volcano, Mauna Loa in Hawaii, is only 10 kilometers or 6.2 miles high. Olympus area stretches across 624 kilometers or 387.87 miles, which is almost as big as the US state of Arizona. Olympus Mons is classified as a shield volcano. This type of volcano has a low slope, giving it a shield-like appearance. Shield-type volcanoes are the result of lava flowing down on the volcano's sides. At the summit of Olympus Mons is a depression that measures 85 kilometers or 52.8 miles wide. But how can such a tall volcano form on Mars but not on Earth? Well, scientists think that it has to do with the lower surface gravity on Mars, combined with the higher rates of constant volcanic eruptions in the surface of the planet. This allows the lava to pile up higher on Mars. Scientists also think that the limited tectonic plate movement in Mars also plays a role in the formation of such gigantic land masses. On Earth, the tectonic plates move underneath the crust, limiting the steady buildup of lava, while on Mars, the limited movement of its plates allow lava to steadily pile up on the same place, thus forming taller land masses, such as the Olympus Mons. Jupiter, the fifth planet from the Sun, coming in with a diameter of 142,984 kilometers or 88,846 miles and a mass of 1.90 times 10 to the 27th power kilogram or 4.184 times 10 to the 27th power pounds. With 67 moons, 4 rings, and an orbit period of 4,333 days, just a little shy of 12 years, with a temperature of approximately negative 148 degrees Celsius or negative 234 degrees Fahrenheit. It's a gigantic planet with a great red spot. Welcome to Jupiter. The planet is named after Jupiter, the Roman god of thunder, who is considered the king of the Roman gods. The Romans, however, were not the first to discover the planet. The ancient Babylonians were the first to write about Jupiter around 7th to 8th century BC. Because of its large size, other ancient cultures also named Jupiter, the planet, after their ancient gods. We have the Greek Zeus, the Mesopotamian Marduk, and the Germanic Donar or Thor. The planet is known as a gas giant, which means that it is mainly composed of gases. Jupiter is made of layers of gases that are composed of various elements, among them ammonia, sulfur, and hydrogen. Its interior, however, is a different story. It is composed of compressed hydrogen gas, liquid metallic hydrogen, and a core that consists of ice, rock, and metals. One of the most striking features of Jupiter is the Great Red Spot, a visible red spot that is actually a huge storm
that has been going on for almost 350 years. Today, there have been 8 man-made spacecrafts that has passed by Jupiter. These are Pioneer 10 and 11, Voyager 1 and 2, Galileo, Cassini, Ulysses, the New Horizons missions, and most recently Juno. International Space Station. Imagine nations coming together to create one of the greatest scientific marvels of the century. A habitable spacecraft in Earth's low orbit. Seems like a good theme for sci-fi, eh? Well, it does exist. Enter the International Space Station, also known as the ISS. A product of the collaborative efforts of governments, scientists, and engineers from all over the world. The ISS is an artificial satellite that is also a livable space station situated in Earth's orbit. It was made by launching modular segments from Earth, which were then connected and assembled in space. The ISS is also the largest man-made body that is circling in Earth's low orbit at an altitude between 330 to 435 kilometers or 205 to 270 miles. The International Space Station completes an approximate 15.5 orbits in one Earth day. It serves as a space observatory and a lab where astronauts and scientists can observe Earth at low orbit and perform various experiments in a low-gravity environment. It is also a place for astronauts to stay and train for longer missions in space. Aside from these, the space station also serves commercial, diplomatic, and other educational purposes as well. In the future, the space station may be used as a port or station for manned missions in space. The ISS is an international joint project between the space agencies of the following countries: United States NASA, Russia's Roscosmos, Japan's JAXA, Europe's ESA, and Canada's CSA. The ISS was first launched in 1998 aboard a Russian spacecraft. More pieces were then added and the space station was ready to be used come November of 2000. The space station has been in use since. The space station also continuously receives new modules, supplies, and parts from Earth. Inside the space station is approximately the size of a 5-bedroom house. It has 2 bathrooms, a gym, and a large bay window, and it weighs in at about 1 million pounds, or 453,000 kilograms. The space station consists of many parts, which are called modules. Each module has its special function, such as life support, communication, navigation, living quarters, and others. Modules are connected to each other by nodes. The ISS is powered by solar arrays, which collect energy from the sun and turn this into electricity. Outside the space station are robotic arms that are used for a variety of tasks, such as builds, repairs, and even moving astronauts outside the space station. There are also airtight doors called airlocks. These function as entrance and exit points for the astronauts. And finally, the space station also has docking ports to dock and connect spacecraft to the space station. Cargo and crew are flown to the space station with the help of the Russian Soyuz spacecraft. Light year. Space. It's so vast that it defies our concepts of near and far. Imagine, for example, the Earth's moon, one of the closest astronomical bodies near our very own planet. You could say that it's near, but how near is near? That's 384,000 kilometers, or 238,855 miles on average. How far is that? Well, it's the distance of 30 Earths, side by side. Now imagine Alpha Centauri, the nearest star system next to our own solar system. It's approximately 41.32 trillion kilometers, or 25.6 trillion miles away from Earth. Now that's far. So how do astronomers measure such great distances without having to write exceedingly long numbers? Well, here's one way of measuring astronomical distances called the light year. The light year is defined as the distance light travels in a year. So, if light travels at the speed of 299,792 kilometers per second, or 186,282 miles per second in a year's time, that amounts to a distance traveled of about 9 trillion kilometers, or 6 trillion miles. At first, it might be a little bit confusing to some, because of the way light year is named. It's important to take note that the light year is not a measure of time, but rather a measure of distance that so happens to be the distance that light travels in exactly a year's amount of time. The light year was first used by Friedrich Bessel in 1838. He used it in an article he wrote about the distance of the star 61 Cygni. At the time, the favored unit of measurement for astronomical distances was the astronomical unit, or AU. The AU was based on the radius of the Earth's orbit, which is 1.50 times 10 to the 8th power kilometer, or 92,955,807 miles. Using this measurement, the distance of 61 Cygni was calculated to be at 66,000 astronomical units, or 9.9 times 10 to the 13th power kilometer, or 6.13 times 10 to the 12th power miles. To illustrate how far that was, Friedrich added a little trivia for his readers. Light takes approximately 10.3 years to travel that distance. Friedrich refrained from using it much though, because the speed of light was yet to be a determined constant at the time. In 1951, however, a German by the name of Otto Uhle used the light year in his articles on astronomy. Today, the light year is used to express great distances between stars found in a general area. Modern astronomers, however, prefer to use the unit of measurement called parsecs, the distance where one astronomical unit subtends an angle of 1 arc second, or 648,000 over pi astronomical units. A parsec is roughly 3.26 light years and is used to measure distances outside of our solar system. Food in space. Now picture this. You are in space with zero gravity. Then suddenly, you feel hungry. It's a given if you're traveling far away, you will need to bring food with you. That being said, let's take a look at some considerations when taking food into space. It should be compact enough. It should have a long shelf life. It should be manageable at zero gravity. And of course, it does help if it tastes good. In 1962, astronaut John Glenn was the first human to ever eat food in space aboard the Friendship 7. Scientists weren't even sure at the time if digestion was possible in space at all. Space food of the 1960s was based on US Army survival rations. This consists of pureed beef and vegetables, packed in aluminum tubes that look very much like toothpaste tubes. The next development in space food came with the Gemini space program of the mid-60s. This type of space food utilized freeze-drying, where Earth-prepared food is flash-frozen after cooking and then heated to remove moisture and water content. The food is then vacuum-sealed and packed. A water gun is used to prepare the food in space by adding in water content to the dried food. In the 1970s, the Skylab program utilized frozen food for consumption in space, since the Skylab did run on water, producing fuel cells. And guess what frozen food astronauts like the most? Same as here on Earth, it's ice cream. In modern times, there have been a variety of space food that astronauts take with them to space. This is due to advances in technology and the increasing international diversity of astronauts in space. The food ranges from Kung Pao chicken, espresso coffee, matcha, sushi, kimchi, goulash, beef, and a wide assortment of dried fruits and nuts.
And that was another
Interstellar trip across the universe. Remember to join us next time for another mission to the cosmos and beyond. Only on Inside Outer Space.